Welcome back to the deep dive. Today, we're doing more than just learning a fact. We're trying to really get our heads around a concept that just completely warps our whole understanding of time. We are diving into Jupiter, the absolute giant of our solar system. When you think of Jupiter, you probably think, okay, massive, the great red spot. But the really mind-bending thing we found is that a day on this huge planet is over. Well, almost before it even begins. I want you to just imagine for a second, you're standing on the edge of Jupiter's atmosphere. You see the sunrise, and then just 10 hours later, not even a full workday here on Earth. It's already setting. You're back in the dark.
It's a huge cosmic contradiction, isn't it? The biggest planet gets the shortest day, and this deep dive is all about moving past that simple number, the 10 hours, and really unpacking the physics that make that speed possible.
Exactly. We're focusing on two big questions. First, why is Jupiter's day so incredibly short? And second, what does that speed actually do to the planet? Let's just jump right in.
Okay, so when you look at the day cycles in our solar system, they're all over the place. Mars is pretty close to us, what, about 24 and a half hours?
Right. And then you have Venus, which is just bizarre. It takes 243 of our days for it to spin just once.
And then there's Jupiter.
Then there's Jupiter. The hard number is just under 10 hours. To be really precise, it's 9 hours and 56 minutes.
Wow, so a whole day-night cycle on Jupiter happens in less than half the time it takes Earth.
Less than half. But just saying 10 hours doesn't really capture the sheer velocity involved.
That's a great point. Because Jupiter is so much bigger than Earth, for it to spin that fast, the speed at its equator must be, well, it must be insane.
It is, absolutely. And that's the key comparison. Here on Earth, if you're standing on the equator, you're moving at about 1,600 kilometers per hour, which is already pretty fast.
Okay, 1,600. Now, Jupiter, to get around in under 10 hours, a spot on its equator is moving at roughly 47,000 kilometers per hour.
47,000.
47,000.
It makes our own spin feel like we're standing still. That's the real difference. Not just a number, it's a velocity.
It's not just moving, it's hauling. And that brings us right to the why. Why is it so fast? The scientific term for it is rapid rotation, and Jupiter is the champion. So, yeah, why does it spin faster than anything else? It really comes down to how it was formed.
Okay.
Jupiter is a gas giant, mostly hydrogen and helium.
Hmm.
So as it was forming, all this gas and dust was collapsing inward. And because of something called the conservation of angular momentum, well, the more it collapsed, the faster it had to spin.
Like a figure skater pulling their arms in.
Exactly like that. The biggest object was almost destined to be the fastest spinner.
But what does that speed, that 47,000 kilometers per hour, what does that actually do to the planet? Does it still look like a perfect marble in space?
That's a fantastic question. And no, it doesn't. That intense rotational speed creates this huge centrifugal force,
Pushing everything outwards.
pushing everything outwards, especially at the equator. So Jupiter isn't a perfect sphere. It's actually noticeably flattened at the poles, and it bulges out at the equator.
And there's a name for that shape, right?
There is. It's called an oblate spheroid. The difference between its diameter at the equator and its diameter at the poles is about 9,000 kilometers.
Hmm.
This isn't just a theory, you can see it. It's physical proof of how fast it's spinning.
That's incredible. The speed literally reshapes the planet. But wait, since it's a gas giant, it's not a solid rock like Earth. How do you even measure one single day? Surely different parts are moving at different speeds.
You have hit on the key complication. Yes, you're absolutely right. Jupiter has what we call differential rotation.
Differential rotation.
It means the atmosphere at the equator actually rotates a bit faster than the atmosphere near the poles. The equatorial region might be closer to 9 hours and 50 minutes.
So what's the 10-hour number we always hear?
The 10-hour figure is the standard. It's based on the rotation of the planet's magnetic field, which is tied to the deeper interior. It gives us a sort of a baseline for the planet as a whole.
Okay, so it's a kind of scientific average for the whole planet's movement, even while the clouds on the surface are all moving at their own pace.
Exactly. The simple fact masks a much, much more complicated reality.
All right, so now we get the mechanics. Rapid rotation, this oblate spheroid shape, differential motion. Let's talk about what that looks like. How does this speed show up visually?
It shows up as this beautiful, organized chaos. When you look at Jupiter, you see those really distinct bands, right? The stripes running parallel to the equator.
Yeah, the classical.
Those are a direct signature of its rapid spin. The differential rotation creates these incredibly fierce jet streams. Some of them are moving faster than 600 kilometers an hour. The gases are just constantly shearing past each other.
So if we were floating above it, it's not just the sun whipping by. The whole atmosphere would look like it's in a race with itself.
A terrifyingly fast race. The planet is in constant violent motion. And while that's spectacular to look at, the biggest consequence of this spin is actually invisible. It's deep inside the planet.
You're talking about its magnetic field.
I am the most powerful one in the solar system by far.
And how does the fast rotation create that?
Well, deep inside Jupiter, the pressure is so immense that hydrogen, it stops being a gas. It becomes a liquid metal. It can conduct electricity.
Metallic hydrogen.
Metallic hydrogen. So you take this enormous ocean of liquid metal and you spin it at a rate of once every 10 hours.
You create a dynamo.
You create the most powerful dynamo imaginable. It generates a magnetic field nearly 20,000 times stronger than Earth's. That 10-hour day isn't just about sunrise and sunset. It's the engine powering the entire Jovian system.
That really puts it all in context. The speed isn't just a fun fact. It's the driving force behind its shape, its weather, and this immense invisible magnetic shield. The planet really is running on turbo.
Mm.
So let's bring this back to us, to the human experience. Our whole world, our biology, it runs on a 24-hour clock. What would happen to us on a 10-hour cycle?
I mean, it would be impossible to manage.
Yeah.
It creates this sense of constant urgency that's just, it's completely alien to us. Imagine trying to schedule your life around a 10-hour day.
Your whole rhythm would just be shattered.
Completely. You'd be fundamentally out of sync with your environment.
I remember the source material talking about this idea of, you wake up, you have some breakfast, and the day is already half over.
Exactly. There's no time to settle in. Before you can even really get started, you're being plunged back into darkness.
Yeah.
Sense of progress, of having a full day to accomplish things.
Yeah.
That would just be gone.
It's a sobering thought, isn't it? Our 24-hour day on Earth gives us this stability. It allows for a certain pace of life.
A pace that allows for reflection, for complexity. Jupiter, with its speed, is fundamentally hostile to that. Its day is too fast, its forces are too strong, its radiation is too intense. It's a world defined by its relentless pace.
Okay, so let's pull it all together. We started with this simple, shocking fact. A 10-hour day.
And we found out this is because of rapid rotation, which gives it that incredible speed of 47,000 kilometers per hour at the equator.
A speed so powerful it physically flattens the planet into an oblate spheroid.
And inside, it creates that differential rotation, those bands and jet streams we see. And most importantly, it spins that core of metallic hydrogen.
Right, generating the most powerful magnetic field in the solar system.
So the 10-hour day isn't really about time, it's a measurement of raw power and speed. It's the signature of a planet that is always, always in motion.
And that leads to the final takeaway from this, which is almost philosophical. When you look at a world like Jupiter, you realize that some places are just so dynamic, so fast, that they don't even give you time to live your day.
It's the ultimate contrast to our own world. Our 24 hours feels normal to us, but it's a cosmic luxury. And knowing a world can exist in such a perpetual hurry, it makes you think about how rotation and time really define what's even possible on any given planet.
A profound thought. Next time you feel like your day is going by too fast, just be glad you're not on Jupiter's clock. Until next time, keep looking up.